an experiment that anyone can do is the double slit experiment, and this is the absolute best experimental evidence against the existence of photons. So here is the basic setup for this experiment. We have a red laser pointer and a diffraction slide. The red laser pointer is a 650 nanometer wavelength. The diffraction slide was purchased from Amazon and is made by 3B Scientific. And here's a close-up of the diffraction slide. So now we can see the wave interference pattern that is created when the coherent light source, or the laser, is shot through this diffraction slide or through the double slit. You have the highest intensity light near the middle, and then you can see the bands of destructive interference where there is no light. So these waves interfered with each other and canceled each other out. And then bands of constructive interference where the light waves add to themselves. So light being a wave through a medium which causes an interference pattern explains this experiment logically. It only gets weird when you add in Einstein's confusion around photon particles and the illogical concept of wave-particle duality for light. So let's go ahead and play along with the idea of the photon particle applied to this experiment. There are plenty of videos that already go into detail about the double slit experiment, but this Dr. Quantum animation seems to be a very popular one. And you can see right here, if you are shooting the idea of photon particles through the double slit, you would end up with two dots or two bands as shown here. But when you do the experiment in real life, you don't see the two bands of these photon projectile particles. So then how do you explain photons making this interference pattern? It is because the photons are in a quantum state superposition. And while in that state, a single photon can pass through both slits at the same exact time and interfere with itself. This allows us to see the photon particles in an interference pattern like this because it is in a quantum state superposition at this time. So if the photon's quantum state superposition were to decohere right now, then it would go back to the two blobs that we saw on the Dr. Quantum picture. As you can see, this is some of the quantum weirdness that people talk about. Sure, it's weird, but it's because it's wrong, not because this is how nature works. So from a particle perspective, you're looking at a fully cohered quantum state superposition of photons. What I'm going to do now is add more noise to this environment to try to decohere this quantum state superposition of photons. Now, why would I do this? This is why quantum computing is not working, is based upon noise in the environment. Quantum computers are not working because they are having trouble maintaining quantum state superposition. And their reasoning is because there is external noise in the environment that is decohering the superposition that they're trying to maintain inside these computers. So why am I able to maintain this quantum state superposition of photons? So someone that understands the story of quantum physics would probably think I'm an idiot for using a heat gun, because in order to collapse the quantum state superposition, I need to measure the photons, not try to heat them up. So if you try to measure which slit the photon passed through, then that will collapse the photon's quantum state superposition. it makes sense because somehow photon particles of light know when they're being measured. Yeah, sure. Right. This is confusing because it's wrong. I want to mention these variations of the double slit experiment because they seem to be very popular. First of all, the which way did the photon go experiment was a thought experiment. Try to find a single photon detector that can detect which side a single photon went through. Again, try to find the definition of what a single photon is. None of this exists. You might see some of these experiments using polarizer material to mark photons as they go through each slit. But this is physically interfering with the light waves. It has nothing to do with photons. As light passes through the material, it can slow down or be absorbed, which is physical interference, not a measurement. And then the quantum eraser variations that I've seen rely on quantum entanglement. Quantum entanglement requires quantum superposition to be a real thing. So we're just going further off the deep end with these experimental variations of the double slit experiment.
You can see the two sides of the beam interfere and cancel out. Again, just like a wave should. Seeing this was the first time that I actually felt in my gut that light is somehow wave-like. Up until now, I just thought that the waves of quantum mechanics were abstract, and they're not. They're actually there, and you can see pretty clear evidence of them. And so since then, I've started taking the whole wave picture much more seriously. On the other hand, I've become more cautious about imagining light as particles. Photons are much more nuanced, clearly, than I thought before, and I want to try and do experiments with them as well to understand how I should be thinking of them.